Alright, welcome back. So we are working on 10.3 in this video. 10.3 leads us to compound interest. So the compound interest formula here is A equals P times parentheses 1 plus R divided by N, close parentheses, taken to the N times T power. Okay, A stands for amount, P principal, R is your interest rate. Of course, you need to change that to a decimal. N is the number of times interest is compounded per year. So that could be annually, it could be daily, it could be quarterly. So please be careful about that. And then, of course, time, and that needs to be in years. Alright, so let's jump right in with a couple examples here. Alright, so example number 1, we're going to use the compound interest formula to compute the total amount accumulated and the interest earned. Okay, so we actually have two answers here that we need to find. Okay. Not only do we need to find the total amount accumulated, we also need to find the interest earned. Alright, so we're going to use that formula that we just saw. A equals principal times, alright, I'm going to sneak a peek just for a minute. There we go. Just wanted to make sure. 1 plus R over N taken to the power of N times T. Alright, so let's plug in the amounts that we know here. Alright, so A is what we're looking for. We're looking for the accumulated amount equals $3,000 times 1 plus. Now my rate needs to be a decimal, so that's going to be 0.04 over. It's compounded semi-annually, so semi-annually, very important here, semi-annually, N is equal to 2 here. Okay, semi-annually meaning that they're going to take it twice a year. Okay, so roughly about every 6 months. So N is 2. And then we're going to take that, let me shrink this out just a hair. Here we go. We're going to take that to the 2 times 3 power. Alright, N times T. N was 2. My time happened to be 3 years. Alright, so let's simplify this a little bit. So A equals 3,000 times 1 plus, let me grab my calculator here, 2.04 divided by 2. That comes out 2.02. And then let's go ahead and multiply that 2 times 3, which is my exponent, and that's going to be to the 6th power. Alright, so let's simplify that and simplify that part right there. Alright, let's take it a step further. A equals 3,000 times, let's go ahead and add those together, 1.02 taken to the 6th power. Okay, so all I did was add the 1 here to that 0.02. Now, the next part here, we're going to have to take that 1.02 to the 6th power. So again, I'm punching this into my calculator, 1.02 to the 6th power. Comes out to a fairly long decimal here. A equals 3,000 times 1.126162419. Now I'm just writing down every decimal place that the calculator gives me. If you have a calculator that gives you more decimal places than that, feel free to use them. We should still come out to the same answer. Okay, so again, that really long decimal there, 1.126162419 times $3,000 comes out to an answer of $3,378. Okay, and we're going to round this to the nearest penny. So it says 0.487, so that'd be 0.49. Okay, so this is the first part of my answer right here. What would be the accumulated amount after 3 years is $3,378.49. Now, the second part of my question, how much what interest was earned, I need to subtract my principal from that. Okay, so to find my interest, I'm going to take $3,378.49 and subtract my principal, which was $3,000. Okay, and we get an interest of $378.49. $2.49. So there are my two answers for example 1. Okay, so I'm going to label up here that this is example 1, so that way if anybody comes back to look at this later, you are more than welcome to. Okay, and you'll know which one goes to which example. Okay, all right. So over on the right hand side, I'm going to shrink this down a little bit more and probably do example 2 right there on the right hand side, and then I'll do example 3 down there at the bottom. All right. So example number 2. We're using the compound interest formula to compute the total amount accumulated and the interest earned. Okay, so basically the same as example number 1. We have a little bit different wording here. Okay, so notice it's compounded daily this time. All right, and so when it's compounded daily, it's telling us to use 360 for n, which is kind of nice because if we hadn't seen n equals 360, then we might be tempted to use n equals 365, which is the number of days in a year. All right, but it ties back to lesson 10.2 when we use the banker's rule. Bankers always use 360 when they talk about compounding interest daily. They always use 360 and not the traditional 365. All right, so we see the principal here is 8,500. My time is 4 years. My rate is 7%. Okay, so everything is still in the same order. I just wanted to talk briefly about that compounded daily. All right, so let me zoom out just a little bit here. There we go. All right, so we're going to put example 2 right out here. All right, we're going to use that same formula. A equals P times parentheses 1 plus R divided by N. Close parentheses, taken to the n times t power. All right, let's plug in what we know. We're trying to find A, which is my accumulated amount. My principal this time is quite a bit more than example 1, 8,500 times parentheses 1 plus my rate, which this time is going to be 0.07. But we're doing this daily, so it tells us n, we need to use 360. All right, and then we need to take that to the n times t power. N is 360. And my time happens to be 4 years. All right, so again, I'm going to do the same exact process that I did example 1 here. I'm going to go ahead and take care of this fraction first, okay, that 0.07 divided by 360. And I'm also going to go ahead and simplify that exponent there of 360 times 4, okay? All right, so let me get on my calculator here. So 0.07 divided by 360. All right, so let's see. A equals 8,500 times 1 plus hang on, I'm going to punch that in one more time just to double check my answer here. Okay, just wanted to double check. Got a really small decimal, so I wanted to double check and make sure that was exactly right, okay? So 0.00019, and I'm just going to use 3 fours here because the 4s keep going on for quite a while, okay? I'm using about 8 decimal places there, which should be plenty. I think in example 1 I used 9, so you know I can go ahead and put an extra 4 there, so that way we're using the same number of decimal places. But again, if you want to use more, that's fine, but we should come up to the same answer. Okay? I would at least use 6 decimal places. Okay, I wouldn't go anything less than that. You definitely don't want to round it anything less than that because it could change your answer, you know, by a few pennies or so, which could, of course, count it wrong, of course. Okay. All right, that exponent, 360 times 4, comes out to 1,440. And so that is my exponent, 1,440. All right. So again, I'm going to go ahead and add that 1 to that really small decimal. So A equals 8,500 times 1.00019444 taken to the power of 1,440. All right, I'm going to highlight my next step in green here. I'm going to take that 1.000194444 to the power of 1,440. All right, so 1.000194444 taken to the power 1,440. All right, so let's see. A equals 8,500 times 1.32309292 952. There we go. Last step there. I just need to multiply that 8,500 by that 1.32309292, and that's going to give me my accumulated amount, $11,246.29. All right, so that is my accumulated amount after 4 years. All right, now, of course, they ask us how much interest is earned. So I equals, we need to take that accumulated amount, $11,246.29, and we're going to subtract the principal of 8,500. And that's going to tell me how much interest accrued over these 4 years. Okay, so that $11,246.29 minus 8,500 gives me $2,746.29. All right, so there's both my answers for example 1 and example 2. All right, now we kind of switch gears here on example number 3, and I'm going to zoom back in just a little bit so we get a little bit closer to it, okay? And I'm going to work this one right below it. All right, so use the present value formula to determine the amount to be invested now, or the present value needed, okay? Now, they're already telling us what A is here, okay? The desired accumulated amount, okay? That is A, okay, in my formula. That is A, okay? Remember in example 1 and example 2, we were looking for A. Well, in this one, we know what A is, okay? We also know what time is, 13 years. Okay? Invested in an account, 7.8%, that's my rate. And this time it's compounded monthly. So that means N equals 12. All right, so we're using the same exact formula. A equals P times 1 plus R over N taken to the N times T power, okay? Now, so the only thing we're missing here is P, which is the principal, okay? And so we already know what the desired accumulated amount is. That's 70,000. Okay? So what we're trying to find here is how much do we need to invest now, and then after 13 years we will have 70,000. Okay? So again, A is 70,000 equals P, okay, which I don't know, times 1 plus my rate is 7.8, so we need to do 0.078. Don't forget, move it over twice. Twice is always the magic number. Divided by 12. And we're going to take that to the 12 times 13 power. Okay, N times T. Alright, again, I'm going to take my highlighter here. I'm going to go ahead and solve that fraction and that exponent as well. Okay? So 70,000 equals P times 1 plus 0.078 divided by 12, 0.0065, 0.0065, and 12 times 13, and take it to the power of 156. Alright, we have to add that 1 to it first before I can take it to the 156 power. So 70,000 equals P times 1.0065 to the 156 power. Okay, highlight this in green. So 1.0065 taken to the 156 power gives me 70,000 equals P times 2.7475 75019. Alright, now we are trying to solve for P here, okay? We're trying to solve for P here, okay? So, this is just like algebra here, okay? We're trying to solve for a variable here, which means I'm going to have to divide both sides by that 2.7475 Because whatever I do to one side, I better do it to the other. Basics of algebra there. Okay, notice on the right-hand side, that will become 1. So that means we're only left with P on the right-hand side. And let me punch this in my calculator. So 70,000 divided by that 2.747575019 comes out to $25,477 and a penny. Alright, so and that's what I was looking for. I was looking for how much do I need to put into this account to make it grow to 70,000 after 13 years. Okay, and so this is how much you'd have to put in, $25,477 and a penny. And then after 13 years at that interest rate, and of course if it's compounded that many times a year, you will have $70,000 after 13 years. Okay. Alright, so that concludes 10.3. And of course if you get stuck on one, please don't be afraid to shoot me a